You want to give this a chance? Yeah, so the challenge is, let me just explain it real quick. So you know what I have here? You know what this is? Let me see. There's water in there, just so you know. So this is a buoyant object.
Yes.
Right? Obviously, right? So this will be considered a simple accelerometer. So an accelerometer detects acceleration. Okay. So the challenge is, when I accelerate this, you know, the buoyant object always gets pushed. It always moves in a direction I accelerate. You know, always, 100% of the time. So the challenge is, I want to see if you can accelerate this container from there to this line in 1 second without that moving, without the ping pong ball being pushed. You think you can do that? If you can accelerate that and the ball stays exactly how it is right now throughout the whole acceleration, you win the $100.
You said to this line right
here? To
here?
this line right here.
Specifically within this?
Yeah, so you have to literally move it from here.
So if I move this entire table right now?
No. You have to accelerate this vessel.
Would that not be accelerating it though?
No. If you're moving this table, you're not accelerating this object. I want you to accelerate this container to this line. In other words, 2 feet, because this is a 4-foot table.
Okay.
I'm literally simply asking for literally under 2 feet in 1 second without the ball moving. You could give it a shot. You can give it multiple.
So you already said that it's gonna move.
Once it's completely at rest, I want you to move from there to the line. I mean, it's moving.
It's moving. You said not in this direction, though.
No. Well, no, it's not accelerating either, and you have 1 second.
So move it without any acceleration. So accelerate it without any movement whatsoever.
Would you say it's impossible? I guess that's my point. Or do you think it is possible?
It's definitely a way it's possible.
You think it is possible?
Yeah.
How can you accelerate this 2 feet in 1 second without? How do you think you can do that?
The same way that whenever you're in a plane, you're flying, you're not accelerating. So if there's got to be...
Yeah, if it's at a constant, I agree. Yeah. It's going to stay centered. But I'm talking about acceleration. From being at rest...
From rest
to 2 feet in 1 second. From at rest, 2 feet in one... Because that will happen in an airplane. That will happen in a car.
I don't think that...
It's not possible, right? Yeah, the fact is it's not possible. It's like me asking you to fly.
Yeah, it's not possible.
This is physics.
I was about to say, yes. From rest, it's not possible.
You cannot break physics. So let me ask you this. If I'm holding this and it's at rest, right? Mm-hmm. And I release it, do you believe it accelerated down?
Yeah.
So let me show you, because the ping pong ball will always get pushed in the direction of acceleration, even when I accelerate down. So out of these two, which one did I accelerate down? The one on the left or the one on the right? Which one's reacting to the acceleration?
Is this being dropped or something?
So both, they were both at rest, but one I actually accelerated down, and one I didn't. So which one?
Because they're both in water, I would say the one that
accelerated down
was this one, the black ball.
No. So the ping pong ball is red. The ping pong ball is the buoyant object is red. And if we understand that the buoyant object always gets pushed in the direction of acceleration, right?
Okay, yeah.
If I'm accelerating
downwards.
Exactly, because the ping pong ball is getting pushed down, right? So the one on the left is actually free fall. And what that shows is that there are no effects of a force. There are no effects of acceleration. So I don't know if you knew gravity is just a theory.
Gravity's just a theory?
Yeah, so what that means is that it's never been physically proven. And the reason why is because there is no physical downwards acceleration of matter. Matter shows that when you release an object into free fall, it's not accelerating down. Because the ping pong ball will always get pushed in the direction of acceleration, and that doesn't happen in free fall. The fact is, I know we all believe that gravity is a pulling force that pulls you down to the earth, but the fact is that the earth is pushing up against you.
Yeah, it's a pushing force.
Yeah, so that the Globers calls it a normal force, but they don't talk about how it actually works.
Okay.
So the earth is literally pushing up against you, moving through space. So if I was to cut the string, what direction will the ball go? What direction will the ball go? That will show you the direction of the force.
I would
go
say
to the top.
Yeah,
exactly. So that shows you that the earth... Again, we understand that inanimate matter cannot move on itself, right? It requires an external cause, an external force. So if the ping pong ball is getting pushed in that direction, what's pushing it in that direction? The water, right? So what's pushing the water in that direction? The bottle. What's pushing the bottle in that direction? The table. What's pushing the table in that direction? Exactly. So do you believe the earth is a ball?
I believe it's a sphere.
Yeah, so if we can, if up is relative on a ball, right? If you're standing here, up is this way. If you're standing here, up is this way. So if up is relative on a ball, and we can prove that the earth is literally pushing up against you and it's not accelerating objects to the earth, how will that work from a ball earth? If the ground is literally moving up, how will that work?
explain? Wait, can you ask the question again?
So if the Earth was a ball, right, and up is relative on a ball,
Yeah.
and we could prove that the Earth is literally pushing up, how will that work from a globe? If the Earth was a globe, if the Earth is moving up. The fact is, it wouldn't work. That would mean the Earth will have to be expanding, growing, so it could compensate for that upwards push. So the fact is, the Earth is not a globe. And people have to believe in this downwards acceleration before they introduce this model. So the number one proof that debunks the globe is that the Earth is literally pushing up against you and it's not pulling objects around. So that pulling force of gravity doesn't exist.
The thing is, how do I explain this? Have you ever looked down the ocean?
Oh yeah.
And if you look down, then you can see steeply starting to curve.
No, I see a horizon, which is
But it
horizontal.
drops off at some point, right?
That's our limit of perspective. So there's a limit
But
to how far.
people have.
No, people disappear over the horizon.
No, our limit of perspective. But it's because we can't see past that depth.
Yeah. So they're
Why
telling
can't
us.
we see past that depth? Because it's starting to curve.
Well, it's because we have a limit to perspective. So the horizon is simply because the
It
horizon
only exists because we see it curve.
So I'm going to show you how the horizon is not actually a physical thing, it's an apparent thing. Because if you're standing here, and it was obviously we're in the ocean, and your horizon is at 6 miles, from the same distance, if I just elevate above you, the horizon extends further.
But why is it that whenever I'm running, right?
Yeah.
And I look 6 miles ahead, I can see 6 miles ahead of me.
Well, it depends if it's an object is taller than
But
perspective
then that
allows.
means that it's curved then at some point.
No, what happens again is
Because
perspective.
then if it's something shorter, then that means it's curved.
So if I move this water bottle away from you, would you agree that it shrinks the further it gets away from you? It appears to shrink the further something gets away
That's
from
only
you?
because of the way that it reflects on my pupil.
Exactly, that's perspective. So we have a limit to how the angle of light enters our eye. We can't see forever. We're not Superman.
Yes, we can't see forever, but what I'm saying though is that you can look at, you don't have to be able to see forever. I'm just saying that if you look in the distance, then you can see a curve.
Well, here's the thing. So you know the size of the Earth that they claim that the Earth is? Because NASA, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they do tell us the radius of the Earth.
The only way that
So this is the radius of the Earth.
would tend to work is if there is a sphere. It wouldn't work if the Earth was flat.
But that's the thing. Gravity is not a pulling force. It's a push, not a pull.
It's both.
It's not both.
It's both.
Well, if you
Gravity is acceleration, right? Acceleration downward.
so acceleration is a cause.
Toward the Earth.
Yeah.
So it doesn't matter at any point. There's acceleration toward the Earth.
But simple accelerometers will not detect that acceleration in free fall. Why is that?
But that's because it's in free fall.
But why?
Look at
What's
your
the difference between acceleration in free fall and acceleration in any other vector? What's the difference?
Because right now, gravity, I'm not falling from. You see how there's no space between my feet and the Earth?
Right.
Whenever there's space between, now there's even more acceleration. Does that make sense?
So here's the explanation from a globe Earth.
Right now I'm not in acceleration. Right now I'm stagnant.
you're at rest. Yeah,
I'm at rest.
Yeah, at rest. So
Right?
here's
so that's different from being at free fall.
So let me ask. So the globe Earth, they claim that when you release this into free fall, gravity is accelerating all the matter inside together. That's what they claim. That's why there's no displacement. But if I was to ask them, well, how did you prove that this kind of force that can accelerate this without displacement? How did you prove that force? Like, can you recreate that force? And the fact is, they can't. And that's why it's a theory. So they're just taking that visual phenomenon.
But it's because it's in water. There's buoyancy in water.
Exactly. So I can reorientate buoyancy by changing the direction of the water.
But I'm saying if you're not in water, obviously when you're in water, there's going to be some sort of.
What direction does a helium balloon go?
The helium's going to go up.
Same principles. The helium is lighter than
But
air.
that's
Just
gas.
like
You're talking about other substances other than air.
put it this way: solids, liquids, and gas, which are the three states of matter,
Yes.
will always reorientate relative to the direction of the force.
Yes.
So the more dense will go to the back of acceleration, and the less dense will move to the front of acceleration.
Exactly.
So right now, where does the dense go? Down. Where does the buoyant go? Up. That's telling us that the force is up.
Because there's another force within this that you're not seeing.
So here's my thing: when the ping pong ball is getting pushed up, the only way it's able to be pushed up is if the water is also moving in that same direction through space. The water cannot be motionless and still be able to push something up. That just doesn't make sense. That's because everything's in motion right now. Everything's moving. Again, that pressure you feel under your feet.
Thus, we're accelerating.
Well, we're at a
How can we accelerate? We're at a constant acceleration.
We're in a constant motion right now.
Yes.
So when you release an object in free fall, it simply decelerates. So the Earth catches up to it. So it's the Earth that moves up to the object. The object doesn't move down to the Earth. But the globe Earth requires you to believe objects go down.
But if you believe that we're at a constant motion, then how could the Earth be flat?
Well, again, because
we're at a constant motion.
Yeah, because the Earth is a level and everybody's up is the same. So we're all standing on the same orientation, moving up with the Earth. There's no orientation here on Earth is singular. It's not relative. So Earth has one orientation. It doesn't have infinite, or not infinite, but like, you know, it's not relative.
You know, I'd probably not be the one to talk to you about this, but if you were to grab like a professor or something,
I've talked to professors.
Because I took physics 1, physics 2.
So let me just show you this. Well, let me explain to you. A cell phone has an accelerometer built in, so you're able to turn it sideways because it detects the presence of a force here on Earth. In free fall, however, if you were into free fall, you couldn't reorientate your phone because there's no force. There's no vertical force in free fall. The vertical force is only present when we're literally connected to the Earth.
You can orientate while it's in free fall.
You need to look that up. That's why I'm out here.
Yes, you can.
So
you're telling me
same
right
thing
now,
with the
if
air
I
bubble.
let this go, right, and I let it drop, it's just gonna drop flat. Even if I tilt it a little bit, then it won't spin.
No. What I'm saying is,
then that's a reorientation.
No. I'm talking about, like, you know how you could change it to portrait and landscape. If you were like in a parabolic flight, which is a free falling airplane flight that simulates zero G.
You don't even have to be in that though. Right now you're right here. You can let something free fall from right here.
Yeah, I get what you mean, but I'm talking about orientation regarding a force present.
That's what I'm saying. But like, we don't need a exact. There's another force present.
No.
I'm saying you have you're talking about other contexts of which something else exists with another force that's there instead of just something plain like a simply organized experiment. If you have multiple factors affecting an experiment, then obviously you're going to have an affected result.
Right.
But if you have a simple experiment, then you won't have an affected result. So that's what I'm telling you right now. If it's just me right now dropping this like this, it will reorient.
Okay. The accelerometer detects G-force. You know what G-force is?
Okay, but the accelerometers are also stacked.
Do you know what G-force is?
Yes.
So we experience 1 G here on Earth when we're connected to the Earth. If I download an accelerometer app and I accelerate this any direction, we're going to get a readment of 2, 3, 4 Gs because I'm accelerating. I'm increasing the G-force, right? The cell phone will detect that. Any direction, down, up, left, right, it will detect the increase in G-force. Guess what happens when I put it into free fall? It decreases. It goes from 1 G to 0 G. So literally showing that there is no force acting on it in free fall. So again, cell phones, whether digital or analog,
because they can't detect gravity.
Yeah, exactly, because gravity doesn't exist.
No, but how are you supposed to detect gravity? The only way you can
matter should be able to detect it by displacing relative to the direction of acceleration. Again,
there's accelerometers that you can use a camera and it'll detect how fast somebody's moving.
That's not an accelerometer. That's just a visual interpretation of it.
No, that's an accelerometer. If it's able to detect and track the speed at which someone's moving, then that's an accelerometer.
How do you know that it's the object moving down towards the Earth and it's not the Earth moving up to the object? Because we'll get the same result visually. So how do you know it's not one and it's the other?
The same way that I know.
When
I move over here, I'm moving to this area.
Yeah, because that's your life force.
It's relative to humans, and that's the reason that science exists, is because it's relative to us. We wouldn't care about anything unless it was relative to us. Right. So why would we care about something that's not relative to us?
The reason why I was doing the challenge, because obviously in 1 second, accelerating this in 2 feet without the spacing, obviously is crazy. You know how fast 9.8 meters per second is? Because that's the claim of a downward acceleration. Yeah. That's 32 feet in 1 second.
Yes.
In free fall. Without effects of acceleration, that's crazy.
You are accelerating.
No, we're moving.
Free fall is acceleration.
Free fall, it's a change in velocity. I agree. But it's a deceleration. And there's a change in velocity from the constant.
It's an acceleration.
No, it's a deceleration.
It's an acceleration.
It's a change in velocity.
Because over time, I'm going to be moving faster as I'm falling.
You're decelerating.
No, you're going faster. So if I'm decelerating, right, you're decelerating, then when I hit the floor, shouldn't I be at a slower speed than when I fell?
No,
according to deceleration rules, because if I'm decelerating, that means that I'm coming to a stop, essentially, right?
I'm going to explain that to you really simple. So if I have an object here,
relative to the Earth, I'm coming to a stop. But relative to myself, I'm going faster.
Okay, if I have 2 cars right here, well, let's say this is a car and this is a car, and I have a bar in between them, right? And this one's behind pushing this one, right? 100 miles an hour, right? And I remove the bar and this one starts to decelerate. This one's only gonna have enough time to decelerate like 10 miles an hour. So it's only gonna be like a 10-mile impact force, right? The further it's away from it, the more time it has to decelerate, the greater the impact force is gonna be.
The more time it has to
the more time it has to decelerate.
Look at your perspective though. this one's accelerating,
It was at constant.
or even if that's at constant.
Yeah.
Look, you're saying this one's decel. This would be the Earth.
No, this is the Earth. The Earth is at a constant always. The Earth doesn't stop and move. It's just at a constant. It's a constant motion. That's why your weight doesn't increase. If the Earth was accelerating, your weight will increase because your body will just be will get pushed down. Because your body has inertia. Your inertia means an object at rest will remain at rest unless there's a force acting on it. So when there's no force pushing on you, guess what? Your body wants to remain at rest, motionless. So it starts to decelerate. So the more time it has to decelerate, the greater the impact of the Earth.
But what you're saying essentially is, because we know that the Earth orbits the sun, right?
Well, that's just all belief, in my opinion. Nobody's actually been higher than 25 miles. All of that is just, you have to believe it. You want to know why people haven't been higher than 25 miles? You know how aircraft function?
Not necessarily.
So aircrafts function, helicopters, airplanes, they all function on the fact they need to push off of the air. And the air has to be at a certain density to be able to push off of it. The higher you elevate, that density of the air becomes less and less and less, and the airplanes are not able to push off of it anymore.
Look at that.
Yeah, they show you CGI of that.
There's no CGI.
I mean, so let me ask you this, because I think this is going to show... are you 100% convinced that the Earth is a ball? Or are you open to that? Okay,
that it's a sphere.
That it's a sphere.
Yeah.
What's the number one proof that convinces you?
Number one proof that
Convinces
I
you?
already explained that to you earlier.
That
when I
the
talked
horizon?
about
That's
the
it?
horizontal drift. Along with that, there's other... It's been proved.
Okay, so if you could see the curvature, should you be able to physically measure it? Because
See, as compared to somebody... Okay, you're able to study and you're able to come up with your rebuttals all day, right?
Right.
I don't study this specific topic enough to come up with enough rebuttals for you.
Trust me, I've heard them all.
But I'm saying if you were to get probably the best professor in here right now, he'd probably be able to debunk some of the things
No,
you're saying.
he can't debunk physics. Physics
Not
is what it is.
necessarily me, but someone in there.
No. Well, real quick, because I know you're stuck with the curvature. So the NASA claims to have satellites orbiting the Earth, which they claim...
Earth's curved. Why is this a circle?
Okay, and the
That
rate...
goes against your own. It's a.
No. This is the numbers they give us. So they're telling us the radius of
But
the
why?
Earth. Well, let me explain. You're jumping ahead. So the globe Earth, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit if they're supposedly going around it. So they need to tell us the radius of the Earth.
Why is nobody falling off the Earth yet then?
I'll get to that one next. So the radius of the Earth is 3,959 miles, and based on that radius, we can calculate using a simple calculation, a squared plus b squared equals c squared, the Pythagorean theorem. We can calculate for this curvature. So again, in 5 miles, there should be 16 feet of curvature. But if we actually went to a giant lake that was miles across to physically measure for this curvature, we understand the physics of water. Again, water, when contained at rest, will always form a level surface, which is horizontal.
Not necessarily.
But they're trying to tell us that the
Not
surface...
necessarily. Water takes place of the container of which it's
Yeah, it takes the
in.
shape,
Takes the
but
shape
the
of whatever it
surface
lies
always...
on.
But the surface is always level. Pay attention
So
again.
no. What about waterfalls?
Yeah, that water is moving. I'm talking about contained and at rest.
No. If it's at rest and if you chop off a piece of it, right?
Yeah.
Will it not fall down?
Yeah.
And move over?
Yeah, the water's being
Okay, then
contained.
that explains to you right then and there that there is some sort of curvature along the Earth, because if there's a chop off, right? Say you have a piece of you have a block right here. Water's moving over the block, right?
Right.
You chop the block.
I'm not talking about moving water. I'm talking about...
Okay, water's stagnant right there, right? You chop the block. Water's gonna start to move downward.
Okay, without chopping the thing, do you think the water can bend without chopping the thing?
But that's the thing about the Earth. The Earth is a bunch of chopped rocks. It's a bunch of rocks that have been molded, moved around.
Have you ever been
know
to a
what I'm
lake?
saying?
You've been
Yes,
to a lake,
I've
right?
been to a lake plenty of times.
Okay, so if we went to a lake that was miles across, like
Then
3
don't
miles
look at
across...
lakes, look at oceans. Because why would you look at a lake?
Have you heard of the term sea level?
Yes.
What's your definition of level?
Level? It's also relative.
So what's level?
Also relative.
So you think level means earth?
Not necessarily. It means where the water touches the land.
But what will be your definition, like a practical definition for
The
level?
water touches the land.
Because I have 2 definitions for level. One is level means horizontal, which is perpendicular to the vertical. And the second definition for level, in my opinion, is no deviation in elevation from any point, any starting point and any other point. So no deviation in elevation. The globe Earth claims deviation in elevation. And it increases more and more and more. So in 3 miles, there should be a 6-foot drop. Again, if we start at 5 feet, that drop should increase to 11 feet. But in 10 miles, there should be 66
There are
feet.
differences in elevation. And you can even see
Yeah,
that
they
here
are.
on...
They are. You know how we measure those differences? From water level. Because water is the number 1 tool to measure horizontal. So any depths or heights are done from the level.
Can you get to why nobody's falling off the Earth yet?
Yeah, because it's being contained. So we have air pressure here, right? 14.7 psi, the air. So in order for air to be able to maintain pressure, it needs to be physically
So
contained.
then somebody has bounced off the side and came back.
Well, not bounced, but I'm sure maybe the government has reached the
But
container
that's
walls.
the thing, though. It's not the government. Other people have traveled and explored.
You need to look up the Antarctic Treaty. Independent explorers are not allowed. So if you were a millionaire, you cannot independently explore this space. There's a lot of restrictions, military restrictions that would not allow you to.
But
No, trust me. You
from
could.
what I remember is that prior to the government existing,
Right.
our government,
Sure,
essentially,
sure.
you know, there was other
Do you
governments,
think
other
history can be
royalties.
altered?
I don't think history seems to be altered.
Yeah.
no?
So how would you, if you believe that people have done it in the past, and you know history can be altered, how can you take those as fact?
How can I take that as a fact?
Yeah, that people have explored this
The
place.
same way that I can tell you, hey, I just took a step right here.
Yeah, that's you doing
I
it.
just
though.
took a step.
I can't prove that people 100 years ago did something. I just have to believe it.
But there's documents. Yeah, exactly. You have to.
How do we
believe
know
it.
those documents aren't being doctored or made up?
Because you can test them.
How do you test them?
You go and you sail around the earth.
Oh, I'm talking about.
That's how you.
Yeah, nobody's actually done that. Physically, the full dimensions of the Earth is unknown. I know that's a hard pill to swallow, but the full dimensions of the Earth have not been explored. So we don't know how big the Earth is
Obviously,
or how small it
there's
is.
estimates of it, though.
Yeah, we have Google Maps. That's a projection. That's not reality.
Not
though.
Google Maps. Other people more sophisticated than Google Maps.
I mean, what's more sophisticated than Google Maps?
What's more sophisticated
Yeah.
than Google Maps?
Yeah.
Google just uses satellite projections.
So what's
talking
more
about the people
sophisticated?
The people that actually get the satellite. Well, then if you believe in Google Maps, then you should believe that the Earth is.
No, what
round.
I'm saying is that they have an idea that they show us, but that's just a projection. That's what they want us to believe. At the end of the day, reality is not a projection. So what they show us in the map.
What good would they get out of lying to us?
Oh, I'm glad you got there. So, well, I mean, you're 100% convinced that they're not, but I'll tell you why still. Okay, first of all, I'm not the one lying, so ultimately I don't know, but I'll tell you my reason. I think it's about control. So it's not about the shape of the Earth. It's if they could get you to believe something that's not true, that means you've been mentally handicapped. So you're going to be more easily controllable now. Because you rather take authority over your own common sense. You rather believe authority.
Wouldn't a flat Earth do that better?
No. The flat Earth is bullshit too. Over 95% of flat Earthers believe in downwards acceleration.
What do you believe in?
I don't believe anything. I go with what reality shows me, that the force is us.
So then, if you don't believe in anything, then what's your argument? What's the end?
Well, I'm presenting facts. I'm not presenting beliefs here. This is what I know. It's either I know something or I don't. I don't have beliefs about objective reality.
But your facts can lead toward a belief.
No, because again, I agree. The fact is that the Earth is pushing up. People have this question. Well, what's pushing up
We're
the
also
Earth?
pushing down.
Well, that's inertia. Your body's resistance to motion.
That's gravity.
No, gravity claims that there's a flow, a gravitational flow.
That's the act of gravity along with your mass. So you're also right. It's also inertia. But guess what? It's also gravity as well. There's different forces. There's different vectors of force hitting you at the same time. It's not all the same.
Two vectors moving in opposite directions. I mean, a vector moving in opposite directions at the same time.
Yes.
That defies physics.
Multiple.
Yeah. So if you have
that's when you get a sum vector that causes you to go in a certain direction.
So when you have
a certain direction is just straight stagnant.
No, well, it's stagnant because of inertia. It wants to remain motionless.
I'm telling you, it's because of you have different vectors of force hitting you at different angles. And
It's only one force, and in inertia is the resistance to that force.
Multiple forces.
Well, I would say that's just a belief.
Is the wind not a force?
So you.
Is the wind not a force?
Yeah. When we're
So
talking
then
about,
that's another force other than inertia.
Sure.
So then that debunks what you just said, that it's just one force.
when we're talking about the vertical force we experience here on Earth, though, is it up or down? That's the question. You're saying it's both. That doesn't make sense.
I'm saying that it's down. When you physically
So how does
gravity, it's downward.
Okay, if it's
right? However, the Earth pushes back up on you. And
how does
for
the
that
Earth?
reason, that's why you're.
Let me ask you this:
because it's an equal and opposite force. Therefore,
how does the
if
Earth?
there's equal and opposite force, then you won't move.
How does the Earth push up without moving up?
You're pushing down on it.
So how does the Earth pushing up? So it's just resisting.
It's equal and opposite force. That's what I'm saying.
So the Earth is
it's
just
a
there.
resisting force.
Okay, so if the Earth is just there,
it's a normal resistant force.
so if the Earth is just there, right, resisting the downwards force. First of all, there is no downwards force that could be measured. So I don't know if you knew Einstein's theory of relativity. Have you heard of that?
And that's why I tell you, there's also orbit around the sun, and for that reason, there's also another force of gravity that we're concurrently experiencing as well.
So
you're not just experiencing one force of gravity from the Earth, but you're also experiencing another force of gravity from the sun, which you can't feel.
So
But the Earth feels it.
Right. So you heard of Einstein's theory of relativity, right? The bending and warping of space-time.
Oh, yeah.
So in his theory, again, it's not fact; it's a theory. He acknowledges that gravity is not a force, and he has to acknowledge that because, again, accelerometers
Oh my God.
clearly
That is
debunk
so
that claim.
nice.
So
what makes you believe in Einstein then? If you can't,
I don't believe him. He's just admitting that the fact.
Okay, but
so-
why are you quoting Einstein if you said if you can't?
Because you keep
relate
claiming that
to
there is a force in
the
free fall,
past?
but even your globe earth priest claim that there's not.
Priest.
Yeah, Einstein is a globe earth priest, just like Neil deGrasse Tyson, just like all of these mainstream
But how are you,
scientists.
the thing is,
They all claim gravity is not a force.
You can't quote somebody for one thing and then quote them for another.
No, I'm quoting them because they acknowledge the facts that I'm presenting, but they twist it. They acknowledge that fact, but then they say gravity's not a
But
force,
for somebody who
but it
studied
is.
that their
But it
entire
still
life
accelerates
and
up.
twist it.
Yeah,
Right? If somebody's to study something their entire life, that's because they've seen it multiple times over and over.
exactly.
And over
Just like
again.
displacement when you accelerate. Exactly.
You know how old Einstein was when he died?
That's irrelevant,
Right?
but
It
sure.
doesn't really matter, right?
Right, it doesn't matter.
But was he relatively old? You don't study that for his entire.
Could he have been bought out?
Yes.
So how do you know he wasn't?
Bought out.
Okay, well then that's just your belief.
Because why would somebody study something that fucking boring for their entire life?
Makes money. That's why.
Not if it makes money.
Yeah, so basically gravity.
To grow an interest in something, you actually have to genuinely love it.
So this is the explanation for gravity. They claim it's not a force, but it acts like a force. That kind of force cannot be replicated though. That kind of force claims that you can accelerate this without that displacement. That defies physics. Can you imagine a gravity machine being able to do that? It won't happen. Here, take my channel. You can check your stuff out later on if you want. You don't want to look at yourself later?
Hey, the guy,
All right, no worries, man. Take care.
Could I call you back after it? I'm gonna keep you updated. But what do you, okay, all right. I will. Love you, and thank you, Mrs. Colombo. That is so nice. Thank you. Bye, guys. Love you. All right, man. I heard you talking about vectors, and I'm a little concerned.
Yeah.
I don't know about that, but I'll do it.
No. It's very easy.
Okay.
So $100 challenge, see if you can do it. So what I have here is a container with water and a buoyant ball in there, a plastic ball.
Okay.
Right? So when I accelerate this, regardless of the orientation, when it's at rest, when I accelerate it, the ball always reacts, right? It always gets pushed in the direction I accelerate, if you pay attention.
Yeah.
The initial acceleration, the ball always gets pushed in that same direction.
Yeah.
You see that, right?
Yeah.
Now the challenge is, can you accelerate this container to this line in 1 second without that displacement?
So without the ball moving?
Without the ball moving, yes.
Can I accelerate?
Yes, do it. You can try as many times as you want. From here to here in 1 second.
Okay.
Okay, that's more than a second already.
Oh, I get it.
Yeah.
So I basically have to slingshot it and twist.
I mean,
And-
even if you use the slingshot, it's still gonna displace. Even if you use air
Wait.
to push it.
Okay. Wait. Can I move it here to here without any displacement?
Yeah,
Displacement is like
the ball being pushed.
without
without the ball moving. Yeah.
relative to the
Yes,
container.
yes,
Okay, I was
yes,
like,
yes,
that's
yeah.
inherently just okay. 1 second.
1 second. That's only a distance of 2 feet, less than 2 feet, because this is a 4-foot table. So
Okay.
less than 2 feet in 1 second. You think it's possible to accelerate it without the ball moving or reacting? Because the ball is always going to react, right?
I'm gonna assume it is possible since this is a $100 challenge, but I'm thinking about how to approach this. Yeah. I noticed it if I spin it. I'm just being purely empirical right now.
But I mean, even the bubble's moving though.
Oh, that counts?
Yeah, that counts.
Okay. But if I'm like very precise, then it doesn't move, right?
But again, in 1 second still.
Yeah.
So here's the fact: it's impossible. So it's kind of like a trick challenge in a way.
Okay.
So the reason why I'm doing this is because again, it will always react to acceleration, right? And even if I accelerate down, it will also get pushed in the direction of acceleration down. So let me show you this real quick. Before I show you this, when I'm holding this at rest, it's at rest, and I release it, do you believe gravity accelerated down to the earth from being at rest? Yeah. So I actually did two tests here. One, I actually accelerated down, and one I didn't. Which one would you say I actually accelerated down? The one on the left or the one on the right? Which one did I actually accelerate down?
Right.
Exactly, right? Because we see the effects of acceleration, the push of the buoyant ball. So in free fall, there are no effects of acceleration because there is no acceleration in free fall. So I don't know if you knew gravity is just a theory. So that means that they never actually measured a physical force in free fall. And the reason why is because matter doesn't react to a force in free fall because there is no force in free fall.
Are you disputing the validity of gravity?
Yes. So the
That's a little crazy for me.
So gravity's not a pull, it's a push. That's basically what it comes down to. Gravity is real, but it's not a pull. It's not pulling you down towards the earth. It's the earth pushing up against you. Buoyancy proves that because if I was to cut the string of this ball, what direction will that ball move?
I'm not qualified to talk about this, but I'm going to trust scientific consensus.
Okay, I would say that's just an appeal to authority, but
No, it's an appeal to quite literally centuries of authority and people who are far more educated than both yourself and myself. And it's proven with empirical data and theoretical.
well, simple accelerometer like this debunks like downwards acceleration. That's why gravity's a theory.
I'm sure if I asked, a physics professor right now and
Yeah.
said, hey, could you come over here and dispute this guy?
Oh, I would love that.
I'm a history major, so I'm not qualified to say, this you're wrong, here's why.
Yeah, I would love to have a conversation with a professor, by the way. They all run away, but yeah. I actually have a YouTube channel, and I do open panel live streams all the time for anybody that wants to come on and talk to me about it. And I also
I'm
do these
all
street
right.
interviews.
I think gravity is real, bro.
No, it is real. It is not a pull, though. It's a push.
Okay.
All right, take care, man. You guys want to try the challenge?
Yeah.
All right, so very easy. Very easy challenge. So here I have this is what I would call a simple accelerometer. And the reason why it's an accelerometer is because obviously I have water inside this container and there's a buoyant object in there, right? So regardless of what direction I accelerate this from being at rest, the ball will always get pushed in that same direction, right? Like, regardless of the acceleration, the ball will always get pushed in that direction. The ball will always react to acceleration, basically. So the challenge is, can you guys accelerate this container from here to this line in 1 second without the reaction of the ball? If you guys can do that, then you guys win $100.
Without reaction.
So you guys have to accelerate this, yes, to this line without the ball reacting to the acceleration.
I can move this in any direction or like.
Well, ultimately, it has to stay at rest, and then in 1 second, bring it from this position, accelerate it to the line without the ball reacting, without it being pushed.
Can I move it horizontally?
I mean, it has to be like that because that's the way I have it laying. And you're still reacting.
Okay, man.
Can you do it vertically?
好烧脑哦，这样的。
No, it has to be done vertically. That's the
Okay.
challenge. That's the challenge.
I can't move it like it just.
You're just always going to react, right?
Yeah.
Yeah, so that's the fact. The fact is that's impossible.
No.
That kind of acceleration without any reaction
Yeah.
defies physics.
Yeah, it's definitely like something you need to think out of the box, but I can't think it right now.
It's impossible. You couldn't do it. I
So
couldn't do
why
it
is
either.
it like a
Oh, really?
$100
Yeah,
challenge?
it's impossible. So no matter what direction I accelerate, and the faster I accelerate, the more it's going to react, right? Even when I accelerate down, the ball gets pushed down in the direction of acceleration. So let me just show you guys this before you go. I have two water bottles here, but I only accelerated one down. Again, the red ball is a ping pong ball that's buoyant, and then the steel ball is obviously dense. But which one of these two did I actually accelerate down? Based on how the buoyant effect, based on the buoyant effect. So I accelerated one of these down. So which one shows reaction?
That one.
The one on the right,
red one,
exactly. Yeah, that shows a reaction to acceleration. The one on the left is actually free fall, which shows no reaction to acceleration. That's because there's no force in free fall.
I see.
Did you guys know that gravity is just a theory?
Yeah, I know.
So gravity, again, the pulling force of gravity has never been actually been proven or measured, in other words, because matter doesn't react to acceleration in free fall, because objects don't accelerate down. The fact is, the Earth doesn't pull you down towards it, it's literally pushing up against you. And buoyancy proves that, because buoyancy, it's an effect of the container that's moving. The buoyant effect will always move in the direction that the container's moving, right? If I was to cut the string right now, what direction is buoyancy?
Yeah.
So the Earth is literally pushing up
I
right
see.
now. So this is the main reason I'm doing this. Do you guys believe the Earth is a ball? So if up is relative on a ball, it's like if you're standing here, up is that way. If you're standing here, up is this way. It's relative, right? In all directions, up. And we could prove that the Earth is literally pushing up or moving up. If we could prove that, how would that work from a globe if the Earth is moving up?
You should go down. You should go up.
So if you're standing here and you move up, well then how will the people down here, how would that work
Go
for
down.
them? So it goes up like this and then like this.
Yeah.
Well, that wouldn't work. It has to be simultaneously. How will the Earth move up simultaneously on a ball? You know, it wouldn't work. It would mean it would have to be growing. It would have to. It would literally explode. It wouldn't work. So the fact is, gravity is a theory to make people believe that the Earth is a ball. Because without that belief that objects accelerate down towards the Earth, then the globe Earth wouldn't work.
Oh,
So
that's
that's
so
why,
interesting.
yeah, that's why gravity is just a theory. So I don't know if you guys heard of flat Earth, right? So this is where flat Earth is a psyop, and in all mainstream flat Earth channels, and over 95% of flat Earthers believe the Earth is motionless. So what does that mean? They actually believe objects accelerate down as well. So then the flat Earthers claiming that are keeping the idea of objects accelerating down in free fall, which is keeping the whole idea of gravity alive, which is keeping the whole globe Earth idea alive. So it's a false dichotomy, the motionless flat Earth versus globe Earth. The fact is the Earth is level because it's literally pushing up against it. That's the fact. So gravity is not a pull, it's a push. And again, buoyancy shows us that. Because again, matter cannot move on its own. Why? That ball cannot move itself up. It requires a water pressure, but the water can't have pressure unless there's a push. That's what pressure is, it's a push. So right now the table is pushing up, the Earth is pushing up the table is pushing up the bottle's pushing up the water, that's creating the pressure gradient, which is pushing up the buoyant object. As soon as we put this into free fall, that pressure within the water vanishes.
I see.
Because it requires
That's
a
pretty interesting.
So this is the number one proof that debunks the globe, the fact that there is no physical downwards acceleration in free fall. It's literally the Earth moving up to the
So what
object.
do you believe?
So I don't have beliefs, I just go with what reality shows me, and reality shows me that the Earth is in constant motion upwards. You know, so the Earth, again, we're all standing on the Earth, and everybody's up is the same. So orientation here on Earth is singular, it's not relative like they tell us on the ball. So again, the reality is the Earth is a level extended plane, and nobody knows how far it extends.
Yeah, it's
That's a mystery. But I believe, well, I don't believe, I kind of tend to go with the fact that when you have air pressure, like in a tire in your car, to maintain that air pressure at a constant, you need a solid container. Because if there's a tiny hole in that container, guess what happens? The air starts to rush out. So the Earth, we have 14.7 psi here of air pressure that's being maintained. What does that tell me? That the Earth is being physically contained somehow. So I know you've heard of people talking about domes. The Earth is covered in. I don't know exactly what the container looks like, but it's definitely being contained. So people talk about, oh, how do you will fall off the edge. It's like, no, you won't, because it's being contained. Nobody's been to the edge or the end. I would call it the end of the Earth, which will be the wall of the container, you know.
Oh, wow.
So let me ask you guys this: are you guys 100% convinced the Earth is a ball, or are you guys open to the idea that maybe we have been lied to?
I think I'm open to any ideas.
Oh yeah, definitely, especially if there's physics to back it up, you know, practical demonstrations. So let me ask you guys this: what's the number one proof that convinces you that the Earth is a ball? Respectfully, if I may ask.
Maybe photographs from the astronaut.
Yeah. So NASA, let me just show you these. I have a couple. So these are official NASA images, and I call them images because they even admit they're images, they're not photographs. So they admit that they have satellites orbiting the Earth, and they take strips of imagery and they make these in a computer. So these are all Photoshop. So a genuine photograph of the Earth from space doesn't exist. Even NASA admits, you know. And even if they didn't admit that and they claim that these were real photographs, well, guess what? These photographs still defy physics. That wouldn't work. So if I showed you a picture of me flying, you wouldn't believe I could fly, right? Because that defies physics. Just real quick before you guys go, the number 2 proof, again, based on the dimensions of the Earth, they tell us the radius of the Earth is 3,959 miles. And using a simple calculation or a Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for this curvature drop every mile. So they're trying to tell us that the Earth is curving 8 inches per mile squared. So if we went out to a giant lake that had water in it and it was contained and at rest, they're trying to tell us that the water is bending 6 feet in 3 miles and increasing more and more and more. But the fact is that any lake on Earth you go, the water is always going to be level, which means horizontal. And a physical measurement of that will show that. Again, they're trying to tell us that water level means this, but water level actually means horizontal. So this will be the number 2 proof to debunk the globe, is the fact that there is no measurable curvature here on Earth. You know, that's why the oceans are called sea level, because level means horizontal. Exactly. So the continents are not around a globe, they're just across the way. You know, it's an extended plane with continents, like a giant pond, pretty much. That's what the Earth actually is. But I mean, do you guys have any questions for me about this subject? I know I'm...
Oh yeah, why are you doing this? Are you from USC?
So, yeah, so no, I'm not from USC. I'm here to challenge the students. I go to UCR as well. I've gone to UC Irvine. So what I'm doing is challenging the current narrative, because online is super censored, this topic. And again, with mainstream flat Earth as well, they have a false dichotomy, motionless flat Earth versus globe Earth, which both believe in a downwards acceleration, which doesn't exist. The fact is literally the Earth pushing up against you right now. And I'm out here talking to people because, again, this is the #1 censored topic on Earth because it's the easiest to prove. And that's why it's the #1 censored. And then they have a lot of controlled opposition. That's the fake flat Earthers. The fact is the Earth is not flat, it's level. Because level is an orientation, and orientation requires motion. So again, the Earth has motion. So that's the fact. So gravity is a push of the Earth, not a pull. So it's literally that simple. So let me ask you guys, if what I'm saying is true, which obviously I'm not going to expect you guys to accept it right away, but if what I'm saying is true, would this be something important to talk about?
Yeah,
like if you
children are educated to okay, Earth is a sphere and Earth is not the center of the universe. They're educated this since they're in maybe primary school, so it's a common knowledge.
Well, that's what they're trying to make it seem. They don't really teach us the globe. They just tell us the globe. If you really pay attention, they don't really teach us like the circumference of the Earth, for example. They never tell us the circumference of the Earth. I had to find this out myself. Because again, once you find out the circumference of the Earth, then you can find the radius. When you find the radius, then you can find the curvature. And the fact is that curvature doesn't exist. And that's why they don't highlight that curvature. Because it's ridiculous. If you go to a lake and when the water's calm and at rest, that surface of the lake will never concave. Water doesn't have that physical ability to do that. Water will always collapse and form an equal surface, which is level, which is horizontal. So again, it doesn't matter, what the size. I can make this container 1,000 times bigger. The water inside will always display level when it's at rest. To claim that it could have a hump that's increasing more and more and more, that defies physics. And that's why I say these images defy physics, because they're depicting water curving around a ball at 8 inches per mile squared, which doesn't exist.
Yeah, I think your thoughts are pretty interesting, but I think it still needs maybe more official scientific treatment. But I think your thoughts is so interesting.
Buoyancy, keep that in mind. Buoyancy, it's an effect of a container that's in motion. So the Earth is the container, and when you release a helium balloon here on Earth, that's a buoyant object. At what direction does it go? It goes up, because that's the direction of the vector. So we do have a vertical vector, except that the globe Earth claims this down. The fact is that vector is up. It's literally that simple to debunk, and that's why it's the #1 censored topic. Do you guys have any other questions? Before you guys go,
actually, we two are not major in physics, so we're our knowledge base for this is kind of shallow. So.
Believe it or not, though, this is kind of elementary physics. It's like a 10-year-old can grasp this. A 10-year-old can grasp that this will always move in the direction of acceleration, which doesn't happen in free fall.
It's impossible.
Proving that there is no downwards acceleration. Yeah, he had a conversation with me first already. So if you guys don't have any other questions, here I can give you my channel. You guys can check it out. I have conversations like this all the time. You guys can take this. I have plenty.
Yeah. All right. Thank you.
All right. Thank you. Thanks for the chat.
Are you going to use this anymore?
You guys can check it out if you want.
Oh, can you not put us up there?
Oh, sure. I can blur your face if you want.
great.
Yeah, no worries. You want to take one too?
Oh no, I'm good.
Okay. All right. Take.